Imagine you are standing in a field in Vermont. It is the 14th of June. The year is 1816. Your boots are wet. They have been wet for 3 days. Around you, the corn, which should by now be knee-high and reaching toward a warm June sky, sits in the ground, blackened, shriveled, dead. You look up. The sky is the color of a bruise, not storm gray, not overcast gray, something older than that, something that doesn't have a name yet. And the air on your face? Cold. June 14th, and your breath fogs in front of you. You are not dreaming. You are not sick. The world has simply changed. 2 days ago, it snowed in June in Vermont, and the snow was wrong. Witnesses across New England described it in letters and diaries as tinged with a faint reddish hue. Red snow falling on dead crops. Your neighbors are already talking about leaving. Your savings are gone. Your children are hungry. And you have no idea, no possible way of knowing that a mountain on the other side of the world killed your summer before it could even begin. Welcome to 1816. The year that didn't have a summer, the year that remade the world. And the story starts not in Vermont, not in Europe, not even in the 18th century, but 10,000 feet above sea level on a remote Indonesian island where the ground itself was about to make a sound that no living human being had ever heard before.
On the evening of April 5th, soldiers in Java thought they were under attack. Here is a detail that almost nobody tells you. On the evening of April 5, 1815, British soldiers stationed on the island of Java, roughly 1,200 kilometers away, heard what they believed was cannon fire. Distant, rhythmic, unmistakable. A military officer named Sir Thomas Stamford Raffles, yes, that Raffles, the founder of modern Singapore, dispatched troops to investigate a suspected battle. Search parties fanned out across the coast, across the jungle. They found nothing. No ships, no battle, no enemy. Because there was no cannon. What they had heard, rolling across the Java Sea at the speed of sound, was Mount Tambora on the island of Sumbawa, beginning to wake up. Tambora had been dormant for so long that the local Sumbawanese people had no cultural memory of it ever erupting. It was simply a mountain. Tall, yes, at roughly 4,300 meters, one of the highest peaks in the region, but just a mountain. People lived on its slopes. Kingdoms had formed in its shadow. The Tambora people, the Pequot people, the Sangar people, 3 distinct cultures with their own languages, their own rulers, their own histories, all of them calling this volcano home. And then, on the evening of April 10th, 1815, it stopped being a mountain.
What happened on April 10th is almost impossible to describe in a way that feels real. The figures are too large. The physics are too violent. So let's try something different. Imagine the loudest sound you have ever heard. A thunderclap directly overhead, a car crash, a jet engine at close range. Now multiply that by a factor that would make those sounds feel like a whisper in a library. The explosion of Mount Tambora on April 10, 1815, is considered by modern volcanologists to be the loudest sound produced on Earth in recorded human history. It was heard, clearly heard, not as a rumble but as a distinct detonation, over 2,000 kilometers away, in places as distant as Sri Lanka to the northwest and the island of Timor to the east. A British colonial administrator on the island of Bangka, nearly 1,700 kilometers from Canberra, wrote in his journal that the noise was so loud as to cause a general alarm throughout the island. In the modern volcanic explosivity index, the scale scientists use to measure eruptions, Tambora scores a 7 out of 8. For context, the 1980 eruption of Mount St. Helens in Washington state, which killed 57 people, leveled 230 square miles of forest, and sent a plume of ash 80,000 feet into the air, scores a 5. Tambora was not 5 times more powerful than St. Helens. It was 100 times more powerful.
The eruption column reached approximately 43 kilometers into the stratosphere. The mountain, which had stood at around 4,300 meters before the eruption, was reduced to approximately 2,850 meters afterward. Tambora didn't just erupt, it consumed itself. The top 1,400 meters of the mountain ceased to exist, replaced by a caldera, a collapsed crater, 6 kilometers wide and more than a kilometer deep. And here is the part they don't put in the textbooks. The 3 kingdoms at the base of the mountain, Tambora, Pakat, and Sangar, were completely destroyed. Not damaged, not disrupted, destroyed. An estimated 71,000 people died in the immediate eruption and its aftermath of pyroclastic flows, those fast-moving rivers of superheated gas and volcanic rock that travel at highway speeds and incinerate everything in their path. The Tamboran language, spoken by the people of the Tambora kingdom, died with them. It is gone. No dictionaries, no grammar books, no speakers. An entire human language, the unique, irreplaceable cognitive universe that a language represents, erased from the earth in a single night. Or so the official count says. But the records show something else, something the casualty numbers don't capture. In the weeks after the eruption, a massive tsunami, triggered by the collapse of the volcanic cone into the sea, killed thousands more across the surrounding islands. And then the ash clouds that blanketed Sumbawa and the neighboring islands of Lombok and Bali caused crop failures and disease outbreaks that contemporary colonial records estimate killed another 80,000 people across the wider region. Total death toll from the direct event and its immediate regional aftermath, somewhere between 71,000 and 120,000 people. But Tambora wasn't done. Not even close, because 150 million tons of sulfur dioxide had just been injected into the stratosphere.
And the stratosphere, you should know, is not the local neighborhood. It doesn't rain there. It doesn't wash clean. What goes into the stratosphere stays in the stratosphere for years. And sulfur dioxide, up there in the cold dark above the weather, reacts with water vapor to form tiny droplets of sulfuric acid. Millions upon millions of aerosol particles, thin as imagination, spreading slowly around the entire planet in the prevailing high-altitude winds. A veil, a shroud, a filter between the earth and its sun. The mountain had spoken. The sky was listening, and everything that happened next, the starvation, the migration, the monsters, the music, the revolutions, flowed from that one catastrophic conversation between a volcano and the atmosphere. The summer of 1816 was not an accident. It was a sentence Tambora had written in sulfur and ash, and the entire northern hemisphere was about to read every word.
Farmers called it 1800 and froze to death. They called it different things depending on where they were standing when it happened. In New England, farmers, who had a gift for blunt biblical language, called it 1800 and froze to death. In France, they called it l'année du mendiant, the year of the beggar. In Germany, das Jahr ohne Sommer, the year without a summer, the name that stuck. But before we follow the trail of suffering across the northern hemisphere, here is something you need to understand about how a volcanic veil actually kills a summer. The sulfuric acid aerosols that Tambora injected into the stratosphere didn't block the sun completely. That would have been almost merciful. At least people would have known something was wrong, would have had a single clear cause to point to. Instead, the veil worked subtly. It scattered incoming solar radiation. It reduced the amount of direct sunlight reaching the surface by only a small percentage. Estimates range from 1 to 3 degrees Celsius of average global cooling. 1 to 3 degrees, barely noticeable on a thermometer. Except that the world's climate is not a thermometer. It is a system, and systems do not respond to disruption the way thermometers do, with a simple linear dip. Systems respond with chaos. In the spring and summer of 1816, the disruption manifested differently in different places, in ways that seemed almost random,
almost haunted, as though the weather itself had lost its mind. Let's start in New England because the records there are extraordinary. In April 1816, temperatures were cold, but not impossibly so. Spring arrived late, but the farmers of New England, Vermont, New Hampshire, Massachusetts, were not yet alarmed. They planted their crops, they hoped. Then May arrived cold, June arrived colder, and on June 6, 1816, it snowed in Albany, New York. Not a dusting, not a flurry, a genuine snowstorm in the first week of June that deposited several inches of snow across much of New England and upstate New York. A man named Nathan Perkins, a Congregationalist minister in Connecticut, kept a meticulous diary. His entry for June 7th reads, and I'm paraphrasing his 18th century prose, that he had never witnessed anything so unnatural. Flowers bloomed one week and froze the next. Ice formed on ponds that should have been warmed for swimming. But here is the detail that tends to slide past people when they read the history. These were not isolated frost events. They were recurrent. The cold came, thawed slightly, then came again in July, in August, killing crops not once but repeatedly, preventing any recovery before the growing season ended. On July 9, 1816, thermometers in Cavendish, Vermont, recorded temperatures near freezing. In mid-August, hard frost struck across Vermont, New Hampshire, and Maine, killing everything that had managed, against all odds, to struggle back to life. The corn was gone, the wheat was gone, the hay, the food for the livestock that would see families through winter, was gone, and people began to move.
The Great Westward Migration of 1816 and 1817, the massive exodus from New England into New York, Ohio, Indiana, and beyond, is often attributed to the simple promise of frontier opportunity, manifest destiny, and all that. But historians of climate now argue that Tambora was the accelerant. Families who had been teetering on the edge of subsistence, who had perhaps been thinking about moving for years, made their decision in the summer of 1816 when their fields turned black and their children went hungry. New York State's population exploded between 1810 and 1820. It became the most populous state in the Union partly because of the climate refugees of 1816. Ohio and Indiana received waves of settlers. Communities in Maine and Vermont that had been growing emptied out almost overnight. Or so we tell ourselves in our comfortable retrospect. The reality for the people living it was not a historical migration. It was a family deciding in late August, staring at a frost-killed field, that they could not survive another winter here. Now cross the Atlantic, because Europe was suffering in ways that make New England look fortunate.
The summer of 1816 in Western and Central Europe was not merely cold, it was catastrophically wet. Relentless rains through June and July washed out the grain harvests across France, Germany, Switzerland, and the British Isles. The rains came not because Tambora cooled the region uniformly, but because the disrupted atmospheric circulation patterns that followed the eruption fundamentally altered precipitation patterns. Cold air pushing down from the north collided with moisture from the Atlantic and simply stayed. For weeks, for months. In Ireland, the potato crop, the staple on which much of the rural population depended, failed entirely. This was 30 years before the Great Famine, but the suffering was, for those who lived through it, catastrophic. Contemporary accounts from County Cork describe people eating nettles in grass. In the Swiss canton of Valais, 1816 triggered what historians now call a subsistence crisis. The historian John D. Post, in his 1977 book, The Last Great Subsistence Crisis in the Western World, documented the statistical reality. Mortality rates across Western Europe spiked measurably in 1817, the year after the failed harvests, as the disease and malnutrition that follow food insecurity did their slow work. Germany was, in some regions, worse. In the villages of Bavaria and Württemberg, grain prices in 1816 and 1817 reached levels that had not been seen in recorded history. People stripped the bark from trees to grind into flour. They ate cats. They ate dogs. Local governors documented riots in market towns as starving people attacked grain merchants they believed were hoarding. And here is the part that the official histories don't always connect. The mass starvation in Europe in 1816 and 1817 triggered waves of emigration from Germany and Switzerland that would permanently alter the demographics of North America. Many of the German-American communities in Pennsylvania, Ohio, and the Midwest trace their founding to this period, families who left not for opportunity but for survival, pushed out by a volcano that erupted on an island most of them could not have found on a map. Tambora's reach did not stop at Europe. In China, the summer monsoon was disrupted. Records from the Qing dynasty document unusual flooding in parts of the country, while other regions suffered drought. In India, the disruption of the monsoon system contributed to conditions that some epidemiologists now believe helped birth the second cholera pandemic, a disease outbreak that would eventually kill millions across 3 continents over the following decades. One mountain, one night, the world unmade.
5 people sat around a fire at the Villa Diodati, and only one of them told the truth about what was happening. Now we arrive at the part of the story that most people have heard, in pieces, without understanding what connected the pieces. June 1816, Lake Geneva, Switzerland. A group of young, intellectually brilliant, emotionally turbulent people have gathered at the Villa Diodati, a grand house overlooking the lake, rented by a man named George Gordon Byron, Lord Byron, the most famous poet in the world, recently fled from England to escape scandal and debt and the wreckage of his marriage. He is 28 years old. He is, by any reasonable measure, a disaster. He is also a genius. With him at the Villa Diodati, or at the nearby Maison Chapuis, Percy Shelley, poet, radical, philosopher, 23 years old, separated from his first wife, traveling with his lover. Mary Wollstonecraft Godwin, 18 years old, the daughter of 2 of the most important radical thinkers in British history, not yet Mary Shelley, traveling as Percy's companion. She is carrying his child. John Polidori, Byron's personal physician, 20 years old, hired help who desperately wanted to be recognized as a literary talent in his own right. And Claire Claremont, Mary's stepsister, 19, Byron's former lover, quietly pregnant with his child. They planned a holiday, a summer on the lake, with walks and conversation and the brilliant alpine light. Instead, it rained. It rained for weeks. Not normal summer rain, the unceasing, gray, cold, Tambora-modified rain that was drowning the Swiss harvest. The lake flooded, the mountains disappeared into cloud. The group was trapped indoors day after day in the Villa Diodati, with a well-stocked library, an enormous fireplace, and nothing to do but talk, and argue, and drink, and challenge each other. Byron, restless and brilliant, proposed a contest one evening in mid-June. They had been reading aloud from Phantasmagoria, a French collection of German ghost stories, and Byron issued a challenge. Each person present would write a ghost story, the best ghost story they could imagine. Polidori eventually produced a story about a vampire aristocrat that would, in heavily reworked form, become Bram Stoker's primary inspiration for Dracula decades later. Byron himself wrote a fragment, a dark, apocalyptic poem that he set aside. Percy Shelley began something and abandoned it, and Mary Godwin, 18 years old, on a cold summer night in Switzerland, in a house they couldn't leave because it wouldn't stop raining, had a dream. Or so the story goes. But here is what the records show. Mary's own 1831 preface to Frankenstein describes the famous dream, the pale student of unhallowed arts kneeling before the hideous phantasm of a man he had assembled, waking in terror at what he had created. She woke from the nightmare, she wrote, with the story fully formed. Except, and this is the detail that scholars of Shelley have wrestled with for decades, there are reasons to doubt the tidiness of this account.
The 1831 preface was written 15 years after the events for a new edition of the book by a woman who had by then suffered enormous tragedy and who had strong reasons to construct a particular mythology around herself and her work. Percy Shelley's diaries for June 1816 make no mention of any particular dream. The idea that a complete novel sprang from a single nightmare is convenient, perhaps too convenient. What is not in doubt is this: the summer of 1816 bled into the book. Read Frankenstein, published in 1818, and the weather is almost a character. The Arctic wastes where Walton's ship is trapped, the glaciers of Mont Blanc where Victor Frankenstein confronts his creation, the relentless storms, the sense of a world out of joint, of nature turned hostile and alien. These are not mere Gothic atmospherics. They are the felt texture of a specific historical moment: the Tambora summer, the ruined vacation, the rain that would not stop, translated into myth. The creature himself, abandoned by his creator, rejected by humanity, driven to violence by isolation, is a figure born in cold. There is also the matter of Byron's abandoned poem, which he titled simply Darkness, and which he wrote in that same rain-soaked summer of 1816. Read it, and you will feel immediately how saturated it is in the actual conditions outside the window. "I had a dream, which was not all a dream," it begins. "The bright sun was extinguished, and the stars did wander darkling in the eternal space, rayless and pathless." He goes on to describe a world in which the sun has gone dark, people gathering fires for warmth, fighting over them, the world gradually dying in cold and darkness. A post-apocalyptic vision of climate death written by a 28-year-old poet who was, at that moment, watching the Swiss harvest fail through a rain-streaked window. Byron didn't know about Tambora. Nobody in the Villa Diodati knew why the summer was wrong. They just felt it. They felt it in their bones, in their nightmares, in the images their imaginations produced when the lights went low and the fire crackled, and someone asked, "Tell me something that frightens you." Tambora created those stories. The mountain erupted in April 1915, and the shock wave, traveling not as seismic energy, but as cultural energy, as dread, as the particular texture of a ruined summer, reached a villa on Lake Geneva 14 months later and conjured two of the most enduring monsters in Western literature. That is not a metaphor. That is what happened.
The famished horse that changed American history and the monster it created. Here is a man you have never heard of, Karl von Drais. He is a German civil servant and inventor living in Mannheim in the year 1816. He has a problem. Horses are dying. The crop failures of the year without a summer have decimated the oat and hay supply across Europe. Horses, which are the primary means of transportation and economic power in early 19th century civilization, hauling freight, pulling carriages, moving armies, are being slaughtered in enormous numbers because their owners simply cannot feed them. The price of horse fodder has become ruinously expensive. Karl von Drais looks at this problem and asks a question that will shape the next 200 years of human civilization. What if you didn't need a horse? In 1817, Drais invents the Lauf machine, the running machine, a wooden frame with two wheels in line. You sit on it and propel yourself with your feet. No pedals yet, those come decades later. But the form, the fundamental form of two wheels in line with a human seated above them, balanced, moving forward, that is the bicycle. The bicycle was in its most direct sense a response to Tambora. The ripple effects of 1816 did not stop at the bicycle. They did not stop at Frankenstein or at the German-American migration or at the New England Exodus. They ran deeper and stranger and further than that. Consider this chain. The famines of 1816 and 1817 contributed to widespread social instability across Europe. Food riots are not merely expressions of hunger, they are political events. They reveal to everyone watching the fragility of governing systems. In France, a country barely 2 decades removed from the Revolution and Napoleon, the restored Bourbon monarchy was confronted with a population that was starving. Louis XVIII's government responded with a combination of relief measures and repression. The political tensions sown in these years contributed to the revolutionary climate that would explode again in 1830 and 1848. In the United States, the great westward migration that Tambora helped accelerate fundamentally reshaped American politics. The new western states, Ohio, Indiana, Illinois, entered the Union with different demographic profiles, different economic interests, different political cultures than the eastern seaboard states from which their settlers had fled. The balance of power in Congress shifted. The old New England Federalist political order, already weakening, lost still more of its base. The era of Jacksonian democracy, of the common man, of Western expansion, of a more aggressive and less institutionally constrained kind of American politics was accelerated, at least in part, by the climate refugees of 1816. And there is one more connection, one more thread in this tapestry that deserves to be named directly: the Mormon Church. In 1816, a 14-year-old boy named Joseph Smith was living with his family in Vermont. The Smith family, like so many Vermont families in 1816 and 1817, were struggling. The farm was failing, the climate was wrong. In 1817, the Smiths joined the westward exodus, relocating to western New York. It was in western New York, in the religiously supercharged environment of what historians call the burned-over district, a region of such intense evangelical revival activity in the 1820s that it was said to have been burned over by the fires of the Spirit, leaving nothing more to convert, that Joseph Smith would, in 1823, claim his first vision and begin the series of events that led to the founding of the Church of Jesus Christ of Latter-day Saints in 1830. Would the Smith family have moved to western New York without the climate catastrophe of 1816? There is no way to know, but the chain of causation is there, documented in the historical record. Tambora erupted, Vermont farms failed, the Smiths moved. A religion was born that now has 17 million members worldwide. Or so the story goes. But the records show something else too, something that the tidy butterfly effect narrative sometimes smooths over. The people of Sumbawa did not cause the eruption. The Tamboran people, the Pakat, the Sangar, they were the first and most absolute victims of the catastrophe whose consequences we trace through history. Their languages, their kingdoms, their dead are the foundation on which all of this subsequent narrative rests. The bicycle, Frankenstein, the German-American migration, or at the New England Exodus, they ran deeper and stranger and further than that. That is not a comfortable thought, but it is an honest one. What a dead summer from 2 centuries ago is telling us about the one we are building for ourselves. We have come a long way from Vermont. We started with a farmer standing in a frost-killed field in June, his breath fogging, his crops black and shriveled. And we have followed the invisible shockwave of a single volcanic eruption across 2 centuries and 5 continents, through famine and migration, through ghost stories and ghost religions, through the death of a language and the birth of a technology that would eventually become the foundation of every bicycle, every car, every vehicle with 2 wheels that has ever carried a human being. All from one mountain, all from one night. Now, I want to ask you something. What does it mean that a single geological event, not engineered, not planned, not caused by human action, could reorganize the political landscape of a continent, birth foundational works of literature, and redirect the migration patterns of millions of people? What does it mean for us in 2024 and beyond when we know, not theorize, not suspect, but know with the kind of certainty that fills peer-reviewed journals and global scientific consensus that we are ourselves conducting an experiment on the atmosphere that dwarfs anything Tambora managed.
Here is a number for you. Tambora injected approximately 150 million tons of sulfur dioxide into the stratosphere in April 1815. That sulfur veil caused, according to best estimates, somewhere between 1 and 3 degrees Celsius of surface cooling in the Northern Hemisphere over the following year or two. The world's nations now emit, collectively, approximately 37 billion tons of carbon dioxide into the atmosphere every single year. Not sulfur dioxide, which cools, but carbon dioxide, which warms. And unlike stratospheric sulfuric acid aerosols, which rain out within a few years, carbon dioxide persists in the atmosphere for centuries. We are not Tambora. We are something Tambora cannot even conceptualize. We are a slow Tambora, a Tambora that has been erupting continuously since the Industrial Revolution, that shows no signs of stopping, and whose effects, unlike the year without a summer, which lasted roughly 2 to 3 years before the veil dissipated, will persist on geological timescales. The year without a summer caused 1 to 3 degrees of cooling. By the end of this century, we are projected to have caused 1 to 3 or more degrees of warming. The numbers rhyme, the direction is opposite, and the lesson of 1816 is that climate disruption of even 1 to 2 degrees in a world that has organized its agriculture, its economies, and its political systems around the assumption of a stable climate is not a minor inconvenience. It is civilizational. In 1816, the disruption was involuntary. Nobody chose it. Nobody engineered it. A geological event beyond human control, as far beyond human control as a supernova, simply happened, and the world absorbed the blow as best it could. The people of 1816 had no warning. They had no volcanologists, no atmospheric scientists, no satellite networks tracking stratospheric aerosol loading. They looked at their dead crops and their red snow and their July frosts, and they called it God's judgment, or they called it bad luck, or they called it the year without a name. Some of them wrote great literature about it. Some of them walked west and built new lives. Some of them starved. We have the warning. That is the difference. That is the only meaningful difference. We have been told with an extraordinary degree of confidence what happens when the climate is disrupted. We watched it happen in microcosm in 1816. We have the tree rings, the ice cores, the contemporary accounts, the mortality statistics. We have reconstructed the event in exquisite detail so that we can watch, in the sediment record, the sulfate spike that marks April 1815, and trace its consequences through the temperature records of the following years. We know. The question is not whether climate disruption causes chaos. We know it does. The question is not whether the chaos will have consequences that ripple for centuries. We know it will. The question, the only question, is what we intend to do with the knowledge. Mary Shelley, 18 years old and trapped indoors by a Tambora winter, wrote a story about a man who creates something he cannot control, something that escapes his understanding and turns against him, something that begs, desperately begs to be acknowledged, to be given a place in the world, to be seen. Victor Frankenstein cannot do it. He cannot face what he has made. He runs from it. He denies it. He tells himself it will go away. And it doesn't go away. It follows him. I don't think it's an accident that the most enduring monster story in Western literature was written in the year without a summer. I don't think it's an accident that it is a story about the horror of a creation that exceeds its creator's capacity for responsibility. I think Mary Shelley, 18, brilliant, sitting by a fire while the ruined summer howled outside, felt something about her moment in history that she could only say in the language of nightmare. We made something we cannot control. We will not look at it, and it is following us.
The mountain on Sumbawa has been quiet for 200 years. The caldera is still there, 6 kilometers wide, a kilometer deep, a wound in the earth that hasn't healed and never fully will. Tourists hike to its rim and photograph it. Scientists drill ice cores in Greenland and Antarctica and find in layers deposited in 1815 and 1816 the chemical signature of Tambora, sulfate preserved in ancient ice, a frozen record of one mountain's conversation with the sky. The world changes on a Tuesday morning, or on an April evening in 1815 when a mountain decided it was done being a mountain. It changed then, and it is changing now. The only difference is that in 1815, nobody saw it coming. You have been warned.
Scientists drilling in the Greenland ice sheet have found the sulfate layer from Tambora. It sits there in the ancient ice at a depth corresponding to the year 1815-1816, a thin, dirty seam in a record of clean white centuries. When you look at it, this faint chemical ghost of a catastrophe that killed over 100,000 people and reshaped the world, you understand something about time that is difficult to articulate but impossible to ignore. The ice remembers everything. It remembers Tambora. It remembers other eruptions, Krakatoa in 1883, Pinatubo in 1991, going back thousands of years to eruptions so ancient they don't have names. And it remembers something else, too. It remembers the steady, accelerating rise of carbon and methane in the atmosphere, beginning in the late 18th century and climbing relentlessly, almost vertically by geological standards, toward the present. Somewhere in the ice being formed right now, in Greenland, in Antarctica, the year 2024 is being recorded. The chemistry of this particular sky, our sky, the sky we have made, is being locked into crystal. In 10,000 years, if there is someone to drill the ice and read it, they will find our layer. They will know what kind of summer we had. They will know what kind of summer we built for the people who came after us. What they will not know, what the ice cannot record, is whether we knew what we were doing. That knowledge lives only here, only now, only in the minds of the people who still have time to make a different choice. The year 1816 had no summer. What will they call ours?